Well, welcome to our DEF CON session on maritime wargaming. In particular, we're going to look at the cyber operations surrounding ports. But first, what I thought I would do is talk a little bit about what we mean by gaming and what we mean by war, and also give you a little bit of my perspective on maritime wargaming and the problem of ports at the operational level of games. So who am I? I design professional games and I teach about such things. I have a lot of experience running these sort of games where you're looking at war fighting at the operational level of war, and I'll talk a little bit about what that is in just a second. I have a lot of experience with cyber game design. I've designed a number of cyber games, professional cyber games, but I'm not an expert on cyber and I don't pretend to play one. However, I have not done that much on maritime cyber gaming, but that's okay because we have two people who have done a lot on maritime cyber gaming that are going to follow me on the panel. But as a game designer, basically, I still have to make a lot of choices about cyber, and in particular, cyber in the maritime environment. So I'll talk a little bit about my experience with those things as well. So what do we mean by a professional war game? Well, I think of professional war games as games, mostly manual games, not digital games, that are played by people who have some stake in the field with which the game deals with. So if you're dealing with a cyber game, it would be professionals who either are like the C-suite in a corporation and the network managers and the cybersecurity team in a corporation that have some experience and knowledge with the subject that they're dealing with. And they would play a manual game to try to either understand, predict, or suss out some issue that they have with respect to the organization or the problem that they're dealing with. This could range from everything from how are we going to fight this war and win, to things like are we organized in the right way to accomplish what it is we want to do? Do we have enough resources? Or, is more relevant here, how is cyber going to play into everything else that we need to accomplish in whatever it is we're trying to accomplish? So these games are mostly manual. They're played by people who are professionals in the field, such as military officers or business people and that sort of thing. And they deal with real subjects that are of usually great interest to the people playing the game. Well, what do we mean by war? Well, war in this concept is between us and what is termed a peer competitor. That usually means Russia or China. And what it really means is that they can actively resist our defensive operations or our attacks, and they have some capability that is roughly similar to what we have. In these cases, that makes things very complicated because this kind of war goes from the bottom of the seafloor all the way up to geosynchronous orbit and beyond. It occurs at speeds that range from speed of light with cyber to hypersonics to ground troops, guy walking down a road somewhere. And so this is called joint, in military jargon, this is called joint multi-domain operations because there's different domains that have to come together and all work together in this kind of situation. As you can see here, I just have one snapshot from one tiny picture of a game we played at one time looking at a peer competitor. And as you can see, it's quite complicated. There's a lot of units on the map. This particular game dealt with information. So, for example, the Chinese were exfiltrating the U.S. surface picture and had a handle on some of the ships based on the fact that they were looking at their charts and their pictures using a cyber attack. And so all of the different elements come together and interrelate. So a cyber attack might set up a kinetic attack. A kinetic attack means putting bombs on the target. And generally what I refer to this as is the stack. You go from space to cyber to command and control, computers, intelligence, surveillance and reconnaissance, issues with ballistic missiles, air operations, naval surface forces, ground, special forces, naval subsurface, and logistics. And all of these interrelate. Cyber in particular can cross all of these various domains. I can use cyber in a space context. I can even more likely use it in a logistics context to screw up your logistics routing. And so all of these different elements of the game of the military power come together in these games in a complex dance that the players have to engage in to try to achieve whatever it is they think they're trying to achieve. And cyber, as I show here, is one element of what happens in these kind of games. And so in particular, one place I said logistics was something that, that cyber could affect. In modern war, the US military in particular runs on stuff, a whole lot of stuff. This stuff can either be prepositioned at the site where it needs to be, it can be flown in, or if it's a lot of stuff, or if it's bulk cargo, it comes across by shipping, and ships have to unload at ports. And therefore, ports become one way to potentially slow down or mess up operations. And cyber is a nice way to attack ports because ports are made generally with concrete and wood. And so sending exquisitely expensive weapons against concrete and wood is not necessarily the best way to go, because you want to send those weapons against things like aircraft or ballistic missile silos or that kind of stuff. And so cyber works very well with ports. Ports also have the advantage of having a big attack surface. I don't care what I attack in the port if it slows down the operation or stops the operations of the port. So if you need to take the stuff by rail or ground transport away from the port, and I can mess that up, I've essentially shut down the port. Even though the port's operating just fine, you still can't get stuff out of it. Likewise, if I can do something to keep the workforce from coming to work, or I can simply shut off the power to the port, all of these things allow cyber to have an influence on port operations, slow things down, and cause, especially the US, which generally has to move all of its stuff to the place where the war is going to happen. It slows us down, or it causes us to have to flex to a different site, and that different site may be less advantageous than the one that we were using. In addition, ports have legacy hardware, so there's a lot of opportunities to deal with ports with cyber. So ports are fairly vulnerable to cyber. Cyber is a good way to go after ports. But in addition, we're talking about maritime here. You think of ships and ports as a component of the overall maritime process. But if you think about things other than ships and ports, there's a lot of stuff in the maritime arena that can be affected by cyber operations. These include things like undersea cables. There's a lot of emphasis on cutting undersea cables or disabling them. Undersea cables have to connect to something, generally power, and generally something's going to feed the light into the cable. Those things are all obviously potentially vulnerable to cyber operations. Likewise, islands need power, they need cables. Islands can be potentially isolated with cyber, and islands perform an important service in a lot of these kind of peer competitor conflicts. So islands are another potential maritime vulnerability. Likewise, bridges, locks, and canals. If I can drop a bridge or make a bridge go shut that you can't sail your ship underneath because it's one of the bridges that opens, I've effectively disrupted your maritime operations without necessarily having to go after something that's a little bit bigger and maybe a little bit harder to port. There's also a lot of synergies between cyber and kinetic. If I can do something with cyber that disables your ability to defend or locates something that I need to attack, that can make my attack much more efficient and help me out a lot. Likewise, in the maritime domain, if you could control something like a ship, if I can take rudder control of a ship, that's a big piece of metal and it has cargo, and sometimes the cargo is explosive. That can work very well in terms of disabling things or messing up your day. And likewise, navigational aids, as well as things like logistic support systems, which often run on barcodes and are used with handheld scanners. If I can affect those kind of systems, I can also affect your operations at the port. So what I'm saying is basically the kind of games that we're going to be talking about are games played by people who actually have a piece of the problem that they're trying to work for understanding or for knowledge. They're generally manual games. They're fairly complex, and in particular, they deal with this multi-domain operation going up against a peer competitor. Cyber is one component of those, and if you think of cyber in the maritime environment, there's a lot of things you can potentially do with cyber and maritime to slow down or potentially disrupt operations where stuff has to come through a port or has to come through civilian shipping and so forth. And with that, I'm going to turn it over to a couple of guys who've actually run cyber games dealing with ports, and they're going to talk a little bit about their experiences first.
Okay, hello everyone. I'm going to talk about designing a tactical cyber war game specifically for educational purposes. First of all, I need to put a disclaimer out, the usual thing. This is my own interpretation of things and in no way represents the views of any government agency or the Ministry of Defense or anything like that. A little bit about me. I used to be a full-time regular Army officer, and I play games. I'm now firmly in the education camp, so I've moved on a little bit since then. So one of the reasons that we want to look at this stuff is because you end up with this problem when talking about cyber with senior people, because what happens is somebody is going to say, well, what's the classification of this discussion? And you end up kicking half the people out of the room. And it's really unfortunate when you do that, because we want to have an intelligent conversation. We want to educate people about cyber at various levels in order to get a bit more of an understanding and demystify the whole thing. And we want to try and do that without going mad into the technical details. So, talking about games for education, we're not talking about training people. We don't want to get into the details of, you know, bash scripts and you know, too much detail. We want to have these intelligent conversations. The other thing we want to do is to give the students a chance to win, because of course, if they lost, they think the game's rubbish. I won, therefore the game is good. But it needs to be a challenge, because this sort of game works best with small groups. So if you're going to split the class up into 3 or 4 groups, you definitely want at least one of the groups to fail, so the others feel that they've earned it when they succeed. The other thing that's interesting and different about educational games is that they don't have to be perfect. They can actually have mistakes in them, deliberately introduced by the guy running it, or by accident. And if the players spot a mistake, it usually ends up with a learning opportunity. So you can end up discussing, well, okay, if it's wrong, how will we make it better? How will we interpret that? What are the alternatives? How could we include that in the game? And as soon as you get people suggesting that, then you have that intelligent conversation going on. So what are we going to hack? Well, of course, the first thing you have to come up with when you're talking about a cyber game is the scenario. Now, if you're doing this for education, you probably don't want to have a real world scenario, because you end up introducing the classification thing that we're trying to get away from. So I normally have the players, the students in the classroom, all playing red, because of course they want to play the bad guys. That gives them a bit more freedom to do certain things. They don't have to worry about the legal guys and stuff like that. And then the enemy that they're dealing with is about to do something with a port, exactly as Ed was talking about, which we want to stop or delay or mess up. Or, for example, as the Israelis did quite recently, the enemy is blamed for hacking something of ours, so we're going to hack something of theirs. But mostly we want to keep the scenario details a little bit vague, because we want to concentrate on the ideas of the hacking attack. So here is a port near Bandar Abbas, which the Times of Israel reported as Israel being responsible for a retaliatory cyber attack in order to mess the port up, which I think they did pretty comprehensively for about 4 or 5 days. So this is the sort of thing that we're trying to achieve. So what are the basic elements of our cyber attack? Well, you need to have resources. You need to have people, and those people need to have expertise. You need tools that they're going to use in order to carry out the attack. You need time, and in many cases, you need money as well. So when you design the game, I normally give them a resource allocation, normally some poker chips or something, which represent people, tools, time, and money. And when they run out of those resources, then they've run out of people and money and time, etc. Then, of course, you have the reconnaissance phase. You want to find out stuff about your target, work out the vulnerabilities, look at the attack surface and see where the areas are easiest to attack. Then you need access. So you want to break into stuff and start exploring and find out the most valuable bits, the things that are going to affect the port for the longest possible time. And then you drop your payload off and you do bad stuff. And then, of course, you might want to exfiltrate if you're trying to get data. You want to get the data out. You may want to persist. You may want to infect different parts of your target so that if they come in and fix one part of it, you can then reinfect it from another part. And then that means you can come back later. And then, of course, you might need to clean up and get your muddy boot prints off the carpet. So perhaps they won't know exactly how you did it. So those are the fundamental things. But one of the things that I like to introduce in the game is the idea of tactics and chance. So when you want to do something, you get two kind of choices. You can do it the easy way, which is the sort of way that a script kiddie would do it. So it's quite easy to do, but it's not very attributable because attacks like this are going on all the time. You don't care because if you succeed, you've succeeded. It doesn't matter whether you've succeeded with a bit of script that some kid could have done, or if you succeeded with some incredibly sophisticated bit of bespoke coding that you've designed. So the point is the easy thing has a lower chance of success, but it is less attributable. Or you can do it the difficult way. Now, of course, the difficult way is more expensive. It has a much higher chance of success. But of course, it's going to be pretty obvious that it was done by a nation state or some threat actors who have an enormous amount of technical competence. So you get two choices. You have to make a decision. What do you want to do? And then I like to add a bit of luck in there because, of course, at the end of the day, you may be ready to launch your cyber attack and we get an update. Something has changed. Keeping your cyber tools up to date is always tricky and expensive. So we've got the low cost option and the high cost option, and we've got a simple roll two dice in order to see. And the results are either, success or failure, or really bad failure, so bad that it's obvious what you've done and they patch it and you can never do it again, or unfortunate success in that you've succeeded in doing what you wanted, but your code might have got out in the wild and it might have affected something else like the local hospital and do things that you didn't want to happen. And then there's this narrow area in the middle where I've called it by success. That's when you're about to do your attack and you realize you need some more resources to make it work. You need Carlos, who's the expert in Linux. Get him down here and do some extra work. So there's this little area where you could try and do something that you thought was low cost, but actually it ends up as high cost because you desperately had to do something with it. So what tools do we give them? Well, the idea is to give them generic tools that cover the areas in which we're interested in. So if you're doing a recce, you could always have a physical survey. And I'm not talking about James Bond here. I'm talking about, some guy in his 50s with his dog who goes for a walk around the perimeter, taking his dog for a walk with a Wi-Fi sniffer in the back of his rucksack and take loads of photos. Oh, you could have social media exploitation, the Robin Sage type, where you're actively creating social media presence and engaging people on the site in order to find out information. Or you might want to do a technical thing by a search engine probing. You can think of lots more. You don't want too many. 6 to 8 is probably enough. Otherwise, your lesson is going to take way too long. I like to run it in about 90 minutes. Don't want to flog it to death. And then, of course, if you've got access, well, then if you've got email addresses, you could try spear phishing. If you found out somebody's recently divorced, is very upset, and who knows, he might be able to be blackmailed, insider threat. And then, of course, you could try something like the complete opposite to spear phishing, password spraying. You're guaranteed to get in somewhere, but it might be the cleaner's email account and not the CEO's. And again, there are lots of other access type capabilities that you can add. And you'll note they've got a low cost and a high cost. If you're doing spear phishing, you need to find out about the person that you're writing to. You need to understand the things that he's interested in, or her that she's interested in, and tailor your email attack to that. If you're trying to recruit an insider, then you're probably going to have to spend a lot of time grooming them into a position where you can exploit them. Whereas something like a password spraying attack is much simpler, but of course it might not get you what you want. And again, you don't want to have more than about 8 of these. And then lastly, of course, you want a payload. You want something that causes an effect at the far end. And that could be as simple as a denial of service on their website, which stops emails getting in or whatever. That's not going to take very long. Or you could do something like the Saudi Aramco attack and trash the domain, just destroy the user terminals there. Or we are thinking about a port after all. Most ports have got industrial control systems dealing with lock gates, fuel pumping, things like that. So if you've got a tool that can allow you to override those industrial control systems, then potentially you can do a lot of damage. And so we give the players these tools, and then, of course, they need to decide on how they're going to use them. So assuming we'd gone for a physical recce, what would you get? And the answer, of course, is you might get details of the Wi-Fi networks. You might get details of operating hours, because some military ports aren't 24/7. They might only operate during the day. You also get to understand the security situation. Are the gates left unlocked? Because of course, if your physical security policy and your cyber security policy don't match, then you're going to be really in a bad situation. And then, of course, you might learn about types of cargo. What is being delivered to the port? Ooh, huge bags of fertilizer. Well, we might want to think about that, because that offers an opportunity to make things go bang in a really big way. So from that, you gain information. From that information, you can then decide on using your tools to access. So, for example, you might be able to compromise the Wi-Fi and get access to different parts of the network. And when you're inside, you can understand the purpose of those parts of the network. Does this part of the network control the lock gates? This control fuel pumping? This control stock levels? This control temperature in a warehouse containing frozen goods or medical supplies, which have to be kept at a temperature? And of course, will give you ability to map the network and give you an idea where you're heading. So you're generating a story based on the student's choices. And then, of course, the payload. Now, of course, that depends on what we found out earlier. If you've done a physical survey, you've identified the Wi-Fi, you've hacked the Wi-Fi, you've got in, and you've discovered you have 2 choices, a set of lock gates or a warehousing system. What do you want to do? Well, both of those, of course, might have user terminals, so I could brick the user terminals. I could make the ICS systems do whatever I want, open the gates, close the gate while something's going through them, things like that, or just prevent the network from connecting outside. What are we trying to achieve? We want to understand that. How much delay? How much damage? How public is it going to be? Do we want it attributable, so it's obvious that it's us, or do we want to pretend it was some script kiddie having a go with a bit of ransomware in order to earn a bit of money? And then at the end, we want to bring out some extra bits of information. So for example, what could you get from open source? I mentioned earlier, you might want to try and shut the lock gate as a ship is passing through. How could you see that? Well, you know, you can go on the internet and see the location of every ship. But of course, the AIS system is about 15, 20 minutes behind, depending on whether you've paid for the service or whatever. But if you have someone doing a physical survey, they could be watching those lock gates with a pair of binoculars or a camera and tell you exactly when to shut it. The other thing, of course, you want to think about is the type of target. As Ed said, these are big facilities made of concrete and wood. And what happens is, most of the time, people have had to upgrade them, and they don't want to dig great channels through 300 meters of reinforced concrete. So as a result, they use Wi-Fi systems. They want to reduce the number of manpower loading and unloading, so they use SCADA systems, which they can control electronically. So if you're looking at this sort of target, often it will be better to try the technical attack first rather than the people. Whereas if you were looking at a hospital or a university, the number of SCADA systems available there might not be quite as many, and you'd probably be better off looking at the human dimension more easily. And then, of course, there's time and space. You know, do I want to shut the lock gates or open them during the day when everyone can see? Would it be better if I did it at night? Would it be better if I did it on a Friday night and there's the whole weekend? You know, that sort of thing. I've mentioned the physical presence, the fact that you could have someone watching to see what sort of effect it has. But then I want to step back a little bit and get people to discuss, hey, just because you're playing red doesn't mean you're the evil empire necessarily. So is what you're doing legal in any way? You know, if you were trying to do this as your own country, would you be allowed to? Also, there's the ethics involved. You know, if you have a tidal port and you've managed to keep the lock gates open and all the water has gone out and the ship that's being loaded has hit the bottom and rolled over, it's quite possible you'll have killed someone. Will you have gone over that line between a cyber attack, which doesn't involve most of the time people dying, and therefore triggered a more kinetic response where missiles and bombs might end up being thrown? So what I've explained is an idea for a tactical game where you can get people to have a conversation about how a port might be hacked using generic capabilities, creating a story. It's a little bit like a fighting fantasy game book. You know, you have your 8 choices. Which one do you want? I'm going to go A. Okay, if you get A, you get these bits of information. If you get B, you get these bits of information. And from that, you get more choices until you finally decide how you're going to attack. So with a number of groups in a classroom, you'll end up with very different results from the way in which they choose to do it. So you end up with a proper discussion. It's very interesting. I do remember doing a game with some very senior officials, and in the middle of it, one of them blurted out to me, "Oh my God, I don't think we should do this." And I said, "Why not?" And he said, "Because it'll give people ideas." And I said, "Too late, chum." Anyway, that's me. Over to John.
Hello, my name is John Curry. I'm an academic in the UK. Any views I express are merely my own and not anything to do with any organisation which you may or may not think I'm associated with. I'm going to talk to you about my gaming, about random lessons from hacking an oil tanker. I published quite a lot in wargaming. What's the important bit? I like to hunt black swans. So at the moment, I'm involved in 2 cyber war games a month with various people, and I'm trying to find the unexpected, the things which people haven't thought of, the surprises, the paradigm shifts. If we can discover these things just by doing a bit of research using Google or just chatting about things, well, that's no interest to me. I'm interested in things which these games can reveal. So, first of all, ports are really, really critical. The way I explain this to people is I say, think of an earthquake in some far foreign land. Obviously, the media likes to show planes arriving with the supplies, and obviously they focus in on the rescue dogs because everyone likes dogs. Actually, the most important thing after an earthquake is those first ships there with those emergency supplies, and that determines how many people are going to survive and how many people are going to live. It's the ports which are critical, not the planes. Now, the rate of attacks on maritime is spiraling out of control. So the figures I've got are the detected rates of attack. Ports have been attacked. Last month, for example, Iran got attacked. I'll talk about that again in a moment. They had a 2-day traffic backlog. Now, ports are being attacked because people realize they're really important, and they have really, really large attack services. The OT systems are staggeringly huge. A large port's got the OT of, I don't know, a small city. Are they being treated seriously by governments? Well, we're just starting to see it now. So in 2019, when the UK is talking about how to introduce autonomous ships and ports, yes, that's right, autonomous ships and ports, they do mention cybersecurity as being a minor issue which may interfere with this great plan. So there's our port. They're absolutely huge, complex, large numbers of people, huge amounts of kit. Actually, some ports have really modern IT systems, but most of them are actually computer museums actually on the seashore which don't allow tourists in. They've got huge capital assets built up potentially over centuries to build that port, but the income from ships is only just enough to pay for the facilities of that port. They have very spare cash. And when you go around and look at these ports, they have kit dated, well, seems like from the 19th century. In fact, I couldn't even work out how to turn on some of the computers because they were so old. If I can't even turn them on, how on earth will I get on trying to hack them remotely? You know. So, what have I found from my games? Well, I refer to Terry Pratchett, really. Terry Pratchett, in one of his books, talks about magic being really powerful, really clever, able to do wonderful things, but most of the time it's simply not worth it because there's an easier way to do it. So if you're out there and you're trying to hack the IT of ports, yes, they really do have Excel spreadsheets and large databases, which are just ideal targets for ransomware. But if you're trying to hack the OT of ports, this is really, really difficult because for most of them, the array of technology is so bewilderingly, utterly ridiculous, where are you ever going to find anyone who even recognizes the operating system being used? And from what I found, you might spend 6 weeks trying to hack the OT of a port and you successfully turn off the lights on Pier 12. Wow, what a successful outcome. And if you do something, the chances are they'll be able to get a manual override very quickly because the kit is all breaking down all the time anyway. So what's the big deal? An example is that someone attributed a nation state to attacking an Iranian port. From what I've been able to gather, they caused a traffic backlog at the port for 2 days. So a nation state attacked another nation state's port, massive resources were invested, presumably in this attack, and they created a traffic jam less than Dover typically has on a bank holiday weekend. You know, in the UK, our ports have traffic jams all the time. We don't need anyone to hack their ports. So I'm going to give you a few clues on how to hack a port or a ship. Now, thinking back to Terry Pratchett, is the hacking worth it? Well, probably not. So why not threaten the insurance value of a ship? Ships cost a lot of money. It's about $81 million if you want to buy a really large ship, by the way. So threaten the insurance, because if there's anything if there's any problem with insurance, the chance of an insurance company to say, I'm sorry, you don't enter the port, you don't do that, you're too valuable. If you want a ship for 24 hours, well, pick up the phone and say there's illegal immigrants on board. That will do it. If you want 48 hours delay on an individual ship, well, get some way, I'm not going to tell you how, I'm giving you clues, some way of suggesting there's anthrax on board the ship. That'll give you 48 hours with that ship bobbing up and down in the water. But if you want 268 hours, well, what you do is you use good old-fashioned sea mines. If you want to buy a World War II sea mine, by the way, they cost 350 euros. You can get them from Ireland. Obviously, they've got no explosives on them, but if you put some of those floating in the water, everyone will recognize it's a sea mine, and the threat of sea mines will close the port because instantly the insurance companies will say, no ships are to go into that port. And that'll give you about 268 hours until they clear it of sea mines. And there aren't any sea mines there, except the polystyrene one, which you've got bobbing up and down outside the port. So if you want to explore hacking an oil tanker, what should you do? Well, you need to do some reading, you need to do some research, play some games saying, right, how do you attack this individual oil tanker? Let's look at this. What are the different options? Let's explore the pathways for evolve. And after the game, this is where it takes longer. You have a technical after action review. We actually talk through and think through technically, great, how do you identify the IP address? How do you identify the operating system? Right, have we got anyone who knows how to look at the operating system? Does anyone know what that SCADA control system does on a 19th century crane, apparently, which is still operating? I exaggerate, obviously. Now, if you run a few of these games, it's not going to take you long to get a good picture of the time, effort, and techniques required. So my advice to you, if you're out there thinking of hacking them, hack the IT systems, but really leave the OT systems for the future. Saying that, I've been following a nation state hacking efforts for a couple of years on this particular project. I follow this particular team. They are so ineffective, it is laughable, but clearly that government doesn't realize it. It's clearly giving them good funding, these people, for reporting effects, and we're just laughing at them. Why haven't we ever publicized it? Well, it's wasting the enemy's time, effort, and money from something useful. So if someone gives you funding to hack a port, smile sweetly, look at them, say, yeah, of course I'll give it a go, but I'm not sure how far you're going to get. Maybe you will tomorrow. Finally, an advert. If you want to learn something about, want to see the basics of cyber wargaming, obviously I published a handbook of cyber wargames, and that gives you a basic introduction to some of the things which we've been talking about. Well, I hope that's got you thinking.
Well, thanks, John. First of all, I have a question for John. What's OT? Can you define it?
Yeah, it's operational technology. It's the technology which runs all these disparate pieces of computer equipment. So you've got, for example, the lighting system will obviously be controlled by computers, but that will be on a completely separate network to the cranes, and that's completely separate to the cranes which are actually on the ships. Everything is separate. So it's the operational technology, it's the computers which control the physical things in the port, as opposed to the spreadsheets which you have for which work out your schedules, planning schedules, your crewing schedules, etc.
Yeah, and my experience with dealing with ports and thinking about attacks on ports, as I often am the one to do, is that I sort of see the same thing you do, that the hardware infrastructure is relatively robust. If I turn off the power, there's other things they can do. If I put a hole in something and they go and look at it and go, yeah, that's a hole, we're going to move over to another dock. And so it's a large area, it's antique infrastructure. It's hard to really affect the core hardware infrastructure of the port. Rather, it's the stuff that surrounds it. It's the ships coming in, it's the ground transportation going out, it's the administrative and what I would call the administrative system, the billing system, the scheduling system, the warehousing systems. All of those systems are a little bit more vulnerable than the physical plant of the port itself. Is that what you were, it seemed like what you were saying too.
Absolutely, it's the IT systems. Yeah, they've got their databases. You'll even find some of the older ones will be using Microsoft Access databases to run their port with. Yeah, they've got their spreadsheets, they've got their project management software. Yeah, those things are vulnerable, just like any firm's infrastructure is vulnerable. And the key thing to worry about is ransomware for those.
Well, it also seems to me that any sort of legacy system is going to be hugely more vulnerable because we've already identified a lot of the failure points and a lot of the entry points for those kind of legacy systems. Like if you're running Windows XP, for example, you kind of know how to get into that. That's not all that great a mystery. So it seems like a lot of that infrastructure will be even more vulnerable because of that.
Well, only if you can find out someone who can work out what that IP address actually controls. So you're looking at it and you're thinking, oh, what actually is this? So unless you've got an expert who can recognize the infrastructure electronically of what you're looking at, you're not quite sure. You start turning things off randomly and hope to see something happening.
Well, Tom, how do you engage that in your games when you're doing the training games that you're doing?
Yeah, I mean, it's tricky. What you need to be able to do is to identify the network that you're in. So in certain cases, we talked about spotting a Wi-Fi network. Well, some of these ports are so huge that you can't detect any Wi-Fi network from the edge of the port. So you'd have to be inside in order to see it. And then once you're in and got access to a Wi-Fi network, we go back to what John was saying. What is that network actually controlling? So you have to sit down and you have to do the packet inspection and find out the messages that are passing back and forth. And hopefully from that, be able to understand what it is you're talking about. But if it's a really old legacy system, the packets of data may be in a bespoke format that you won't be able to decode unless you've got someone who's expert on it. So it can be very difficult. However, in some ports, it can be very easy because someone's come in, put everything on the same network to make it life easy for them. And of course, once you're in, oh my God, you've got the crown jewels. You've got access to the main router and you can switch from any part of the network to any other part of the network and you're away. So depending on the size and the scale and the age, every single port is different. But there is this bit of you have to get in and then you have to do a reconnaissance to find out where you are in the network. Am I dealing with the cleaners reorder program for more toilet rolls and cleaning materials, or am I dealing with the stock control system for the fundamental running of my automated container crane? Because one's really important and the other you could probably do without for a few days or more. Yeah.
And when you get into my kind of games where you have these large operational things going on, and someone's invested all that time and effort to go after, let's say, pick one, Rotterdam, for example, and suddenly Rotterdam goes down, everybody goes, just okay, we're going to shift to Bremerhaven, or we're going to shift to Brest, or we're going to shift to another particular port, and you're going to have to go through that same process for that other port, and unless you've already done that, you're going to be several weeks behind the overall flow. So cyber is not necessarily a silver bullet sometimes. Is that what you guys experience?
Yeah, but there are some, occasionally you can end up with ports that are single points of failure. So for example, if you're moving ammunition, the net explosive quantity of ammunition that you're allowed in a port or that you can fit on a ro-ro ferry can be very small. So if you've got access to a port like Rotterdam, which has enormous ships coming and going, the amount of explosives that you can move in there safely is much higher than many other ports. And if you prevent Rotterdam from working, suddenly you're going to need a whole lot more shipping because the amount of ammunition that you can move in a single lift might be reduced. So there are peculiarities. You can look for these single points of failure and then do stuff that encourages people to move to this other port, and then that other port is vulnerable for something that you're attacking. But there is, ports do go down. Ships do crash into each other and block the port for days. So you have to be aware that it could move. And the other thing that John said is quite a lot of these systems are breaking down all the time. So if you turn it off, the guy just goes to the manual override. So that's where that bit that I said about the timing and when you do it, and if you can get something else happening at the same time, you know, arrange a demonstration at the front gate while you're doing it in the hope that nobody sees, that sort of thing.
Wasn't that kind of like what happened in the Ukrainian power hack, where they took off 2 or 3 counties essentially worth of power, and about an hour later, somebody just went down to the circuits and flipped a switch, and everything went to manual, and it was back on,
Yeah.
even though they had done this rather exquisite attack to go after the backup power systems and all the various controllers, and they just turned a switch and it was on manual, and they're good to go. So.
Well, hang on. Analysis of the network logs showed that the attackers made a mistake with the IP addresses. Their plan was to turn off the surge protection, and the warning the surge protection had been turned off. So when the operators turned the switches back on, the plan was to kill the operators in a massive explosion. But it failed because they had the wrong IP addresses. The logs were leaked to some UK company which figured this out. But yeah, you're right. British ports are fairly immune to hacking because they're in chaos all the time.
Yes.
However,
Will we even notice?
Yeah. However, we're on the cusp of something new. We are seriously talking about, within 20 years, autonomous ships on autonomous ports going on to autonomous vehicles. So a British supermarket is going to expect a ship to come with no crew on there except possibly a caretaker from China, dock at Southampton. It's going to be unloaded by a robot, put onto a robotic vehicle, and off it's going to deliver it to Birmingham. And we're at the cusp of this new. And if we build in security technology now, it will cost peanuts to add this in compared with the cost of getting these systems. Absolutely. But if we wait until the other side start hacking these things and we have to retrofit the security, it's going to cost an absolute fortune.
But isn't that always the argument that businesses would make, is that my investment in cybersecurity has to have a return on investment, and if I look at my ROI for those kind of investments, I just pay the cost of doing business and move on?
There is an element of that, but of course, if you do your cybersecurity, you should view it like insurance. So you know, there are a lot of insurance companies now that offer insurance for cyber attacks. So of course it's self-defeating. You know, it is part of the cost of business. I'm insured against it, so we'll just carry on. And you know, the poor people in Birmingham who suddenly find that their shopping centres all run out of food. Yeah, well, I'm sorry, that's the cost of doing business. So yeah, there are all sorts of dangers with these incredibly complex interconnected systems.
But so, John, how are these AI systems going to interface with the obviously 1960s technology of the ports?
Well, it's market forces. What will happen very quickly is the first countries and the first ports which introduce the highest levels of autonomy will become so much cheaper that you will just then outcompete everyone. Everyone's going to use your port because your port will work 24/7, 365 days a year. So for example, in the UK, if we say you had to click Southampton to take autonomous ships, all the autonomous ships delivering to Europe are going to come to Southampton and offload onto smaller ships. And that would give the UK such a market advantage. Whoever gets there first, fastest, you know, you could be able to cut the cost, I don't know, of transport drastically. However, the UK government is thinking of these things, and cyber is going to be critical because the thought of a large oil tanker coming into a major British port with no one on board, not even a pilot, and being unloaded by a robot, cybersecurity is going to be critical.
Where do you get your LNG deliveries, by the way?
Another state, not far away.
Yeah, that's one of the things we didn't talk about very much is petroleum and fuel and LNG type products, which also come through ports, but they don't come through quite the same way. Sometimes they have offshore offshore sites where they have to go. They also represent an environmental risk if there's a spill, as opposed to just an operational risk. And so, have you ever looked at anything like that?
Yes, I mean the issue is that most of those are not automatic. So at the moment, you can switch feeds, you can interfere with the pumping stations and do things like that. But it's actually very difficult to turn them on and get them pumping without somebody running there rather quickly and setting them back off again, because it is those you get spills and you get mistakes happening all the time. So when it's dealing with pumping, when you're dealing with fueling, people are always very worried about it. So in order to get a marked advantage with a cyber attack on a pumping station, you've really got to work at it in order to get the effect you want.
Yeah, sometimes kinetic attacks are the best way to go, as opposed to putting all your money in cyber. Well, I hope this was somewhat informative for everybody. Like I said, we wanted to talk a little bit about maritime cyber and its use in these type of professional games, either for training or for understanding. And we basically covered a lot of the issues, but certainly not all of the issues. And thank you for your attention, and thank you, Tom and John, for participating in this session. Thanks a lot, everybody.